Anthony Bear is probably, if you pushed me, my favourite flat earther. Partly because he's pretty much harmless. I'd certainly love to go for a beer with him. But also because he gets things incredibly wrong. And this week on Flat Earth Friday, he's going back to what he does best: get things wrong. Hello all and welcome along to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Before we begin today, a massive thank you to the sponsors of this video, Raycon. Raycon's everyday earphones are the perfect partner for the gym, work or phone calls, offering premium audio that goes where you go. This latest model is better than ever, with a 40-hour battery life and a comfortable ergonomic design that you'll love to wear all day long and beyond. These are genuinely the most comfortable headphones I've ever tried. No more earaches for me. The quick charge function, by the way, is amazing. 15 minutes of charging yields 2 hours of battery life. So useful, that function. And the noise cancellation is brilliant. Just the other day I was listening to my ebook whilst in a busy coffee shop. I couldn't hear any background noise at all. It really meant I could focus on my ebook. And if you don't fall in love with your Raycons, they offer a 30-day happiness guarantee returns policy, no questions asked. Go to buyraycon.com/SimonDan20 where all headphones have 20% off. That's right, all headphones are 20% off on Raycon's website when you go to buyraycon.com/SimonDan20. Right, on with today's video, which, as I said at the start, is from flat earther Anthony Bear. He's at his local beach and he's got a transit with him. All the joys. Take it away, Anthony.
Okay, it's time to take the transit to the beach. And let's see what kind of observations we make. Basically, we're going to be looking for curvature. If you want to get right to the point, go to 4 minutes and 35 seconds. Let's take a look at this preliminary observation, almost 6 miles. I'm using a 25 power scope and having almost 5'2" off the ground. So here's a guy standing here about a few hundred yards away, and this corner right here is about almost 6 miles away. Let's take a look.
Okay, so Anthony has set the scene quite nicely. We've got a viewer height and I expect we're about to see some distances. Keep it up, my friend.
Here we are at Vanderbilt Beach, and I'm on the edge of the beach looking between these two buildings at some new construction in here. Okay, so let's see how far that point is. That point is Doctor's Pass. So let's cruise up this way. This is a Clam Pass. All right, here's Doctor's Pass. 5.6 miles away.
Great, 5.6 miles. Excellent so far.
So let's start out roughly where I think 5 feet is. Person to the right getting hit in the chin is a lot farther away. Now let's follow the shoreline using the instrument. And basically you can see how it runs pretty flat with the shore. So right here is 5.5 miles away. There's that little tree. I'm going to try to readjust it here a little bit. What I think is about 5 feet or so. Then we take off to the left. It just follows the shoreline right down. Nails the guy in the back, nails the guy in the chin. That's about 5 feet. Now this is just preliminary. At this far point, there should be 20-some feet of curvature. And when you're looking through it, it's pretty easy to see that there's not.
Okay, so I'm not entirely sure what you're trying to claim here. That the horizon is level at both distances, I assume, and the one further away should be lower. But the thing is, if you look at your footage, your equipment doesn't seem to be properly calibrated. Your crosshairs don't look level for starters. The left side looks lower than the right. I suspect this could be a theme for this video.
Okay, let me show you another quick observation. Okay, here's a nice clear day, and the machine back there is like 3.25 miles away. And I put it on the guy's head back there. And then, look at this guy. This guy's head lines up. The guy in the red shirt, right in the head, boom. This guy in the head. So you can see, like, it's a quick observation, everybody's head lines up.
Even though people are all different heights and walking at different levels on the beach. But yes, please continue.
As long as they're standing on the water's edge, the same as the tripod. Now remember, we're just taking a look around right now. Okay, now we're going to get a little more accurate using a 2x3 red marker and actual distances.
He hasn't just set that up on the beach, has he? Oh, wow. Okay, great work, Anthony. Please continue.
So here we set our transit up at Wiggins Pass beach access right here. Now we put our first flag about right here, right there, 1.1 miles. And then the next flag we put it almost to Clam Pass, 3.4 miles away.
Okay, two flags, one at 1.1 miles and one at 3.4 miles. Gotcha.
We set the transit up at 60 inches off the water's edge, and then we set our flags up at 60 inches off the water's edge. Let's take a look. My wife is holding this marker. Red flag right there.
Okay, you see me?
Yeah, red flag right there. My friend Mike is holding the other marker.
Yeah, on the money.
Alright. Yeah, 60, I got it.
It looks pretty close, right?
Yeah.
I can't zoom in because
I know.
with the video.
Yeah,
but,
yeah.
all right, so I'll call it there.
That's it.
Okay, so there should be a discrepancy between those two flags. At 1.1 miles away, there should be about an 8-inch drop, and at 3.4 miles away, around a 6-foot drop. The problem is, I suspect that Anthony has tilted his transit down slightly so it's level with the top of the first card. That means by the time he gets over to the second card, he's removing a lot of that expected drop because of that tilt. His transit is not level at all. In a discussion in the comments of his video, he tells Ruhif, "Yes, I mounted a rifle scope on the top. Horizontally it's not level, but the center point is what I'm using. The mechanics of the transit are set to level." Mounting a rifle scope? How on earth do you expect to get accurate results with that?
The experiment came out great, but I want to try it again from the other direction, where the sun is facing the other way. So let me show you that one, and this one we're going to really document it. Okay, so we mounted the first flag at Wiggins Pass beach access. And notice how we put the flag right where the water ends. This way we put the flag in the same spot in all the places. And the tripod. Okay, here's our flag, and then there's the condo that's right next to the Wiggins Pass beach access. We set the second marker a little bit past the last tall condominium.
No prizes for guessing the results of this one as well.
So we got our tripod set up on the water's edge. And this time we're right next to the woods. There is no buildings. The far target is all the way to the left of the photo. There's no way you can see it with your naked eye. From the tripod, our first marker is 0.8 miles away. And you can see here, it's a little bit past that last tall building. We set the transit at 60 inches, and we set our markers at 60 inches. And from the transit, we're 3.1 miles away from a little bit past the Wiggins Pass beach access. And here's the observation. Of course, the wind spun the first marker around, so it's not red. We lined up the corner. And it lines right up. I don't know about you, but 2 observations in a row, the marker lines right up. I find that fascinating.
As do I, Anthony, as do I. But tilting the transit to the top of the first card will have exactly the same results.
The ultimate goal is to line up the flags in a row, which I try to do, but you can see they look like they're off a mile because it's magnified. So when I'm moving left, it looks like I'm moving far. But look, it's only a few degrees off here. So I mean, there's not much. It just looks like it's way to the left.
Absolute shock that you can't view them in the same frame together, Anthony. That would have been a much better experiment.
Okay, so let's do the math here. The top one is a flat earth model, and you just line up the flags and you're done. Makes a ton of sense, especially after the observations too. The round earth model, here's the math of a globe that we supposedly live on, and this is the math calculations that they give us. So, okay, so at 0.8 miles, it should be 5.1 inches of drop. And over here at 3.1 miles, it should be 76.9 inches of drop. Okay, so now if we take the scope and line it up on the first flag, that means down here we should have, you take the 5.1, you times it by 3.1, and you get 16 inches of drop. So if you take 16 off of 76.9, there should be 61 inches of air above this marker, but we don't see that. So it doesn't match the globe.
It's interesting to me that you factored that into your experiment. The problem I have though is this. There are far too many variables in this experiment that can affect your results. The shoddy workmanship on your transit, the atmospheric turbulence which you can see in your footage. Are the flags the exact distance from the water's edge as you are? The fact that your transit is not properly calibrated. The list goes on and on. Couple that with the refraction going on that day and you can see why this is not exactly a great experiment. Huge kudos to you though, Anthony, for trying. I'll never mock you for that. However, on this occasion, you're incorrect. Well, there we go. What do we all think of that one from Anthony there? Let me know in the comments below what you thought of that experiment. As I say, we're all done and dusted for another Flat Earth Friday. Thanks so much for watching today. It truly is appreciated. If you enjoyed it, please do consider subscribing to the channel, hitting the thumbs up button too, and sharing the video as well if the feeling takes you. Thank you. Just enough time to once again thank Raycon for sponsoring today's video. Remember, go to buyraycon.com/SciManDan20 where you can get 20% off all headphones on the Raycon website now. I've been SciManDan. Have yourselves a great day and I'll see you tomorrow for another Saturday session with something new again. See you then.